Good afternoon and good morning to the people joining us from the Dominican Republic. My name is David Puig, and I'm the ambassador of the Dominican Republic in India, for those who don't know me yet. I welcome you all to this two-day seminar, online seminar with the Earth Institute of Auroville, dedicated to Dominican architects and engineers. And I would like to thank in particular Mr. Satprem Maini, who is the director of the Earth Institute and really a legend in earth architecture, and Omar Rabie, lecturer at the Auroville Earth Institute, for having welcomed the idea of the Dominican Embassy in India to organize this seminar. We do feel really privileged to have them both sharing over 2 days what the Auroville Earth Institute does, and to start introducing us to the techniques of building it promotes in India and around the world. I would also like to thank from our embassy, Anna Ferrand, in charge of culture, who has been instrumental in having us all here together, ready to start the program. I won't say much about the Earth Institute or Auroville or the program that will happen in the next 2 days, because we have shared with everyone, the basic information about the program. And anyway, Satprem Maini will start by presenting right away the Auroville Earth Institute. I would just like to stress that we have conceived this 2-day seminar as the start of a relation between the Dominican Republic and the Auroville Earth Institute that we hope can grow over the time, depending, of course, on the interest of the architects and the engineers in the Dominican Republic. We have envisioned, dreaming a little bit, that after this course, we could think of further steps that can allow to more substantial exchange of knowledge. We could have, for example, Dominican students and architects attending the presential courses of the Auroville Earth Institute, or professors from the Earth Institute traveling to the Dominican Republic and developing projects with Dominican architects and engineers on site. The possibilities are immense, but we will start with these 2 days. First 2 sessions today, following by 2 sessions tomorrow. And just to conclude on a personal note, as someone who is curious about architecture and worried about the future of the planet, I am really happy to contribute to the connection between the Dominican Republic and the Art Institute. So Satprem, thank you very much. Though we have not met in person, I hope it will happen soon with a visit to Auroville. And very grateful that you have accepted to share your knowledge and your work with the Dominican Republic. Thank you very much, and you have the floor.
Okay, thank you very much, David. So let's start now. I will share my screen, and this one. Okay, so let's start. So I will present first who we are, what we have been for the last almost 33 years. And let's start now. So we are located in south of India, southeast of India. We are about 8 kilometers north of Pondicherry, 140 kilometers south of Chennai. So about our institute, we have been founded in 1989 by HOTCO, which is the Housing and Urban Development Corporation. And we have the representation for Asia of the UNESCO Chair of Architecture. We have a membership of members of a World Network. We have received 15 awards, finalists for 2 other awards, and activities mostly training and education, applied research, publications that we sell, consultancy worldwide, construction worldwide, and a little bit of heritage conservation. This is a minor activity for us. So we mostly research, develop, and promote earth-based technologies, and dissemination and transfer of earth architecture worldwide. So we have been working in 38 countries, so all over the world. I was recently in Syria. I just came back last week. We have been training people from all over the world. You will have more information on that later. So I was in Haiti. In fact, I worked in Haiti after the earthquake, but I did not go to your country. I was close by, but I did not go there. So our mission statement is to revise the traditional skills and to link ancestral and vernacular traditions of raw earth construction with the modern technologies of stabilized earth. To enable and empower people to build their own dwellings with earth, to develop cost-effective technologies affordable to all, and important for us to respect our Mother Earth while using its resources to build a sustainable future. So we try to demonstrate that earth as a building material can be used for creating a modern, progressive, eco-friendly, and safe habitat. So our premises, which are developed over the years, according to the needs of the development of the Institute. We started with this building here in 1999, this also in 1999. This was built in 2000. So our philosophy on sustainability, we lay a lot of emphasis on the proper management of both human and natural resources. And we place first human resources, because if people, they know what to do, then they can have a proper management of natural resources. So we give a lot of awareness programs, training courses, educating people to allow them to manage properly their resources and to give them a livelihood and a skill. And then comes after, for us, the natural resource management, because people, once they know what to do, then they can manage properly the resources. To have a properly built environment using the natural resources. It is possible to use earth, especially in respect for nature and for people. So we have trained a lot of people from all over the world, on all continents. A few examples of people that we have trained here. And then comes the natural resource management. So examples of what we have done in Auroville here. So we have taken the earth to build here, for example, we have taken the earth from this wastewater system to build 4 apartments here. This is a rainwater harvesting system. Another one, another rainwater harvesting system. A basement floor or to the earth to build 4 floors above. You will see photos after of this one. Different wastewater systems here. Water systems here from the well. So we always use the soil from the side for the construction of the buildings, and we rehabilitate the quarry into something useful for the development of the place. So now we'll develop the training activity that we have done in Auroville. We started in 1990, but we were founded in 1999. So, hello? Yes? Hello? Everything is fine? Okay, yes. Let's go on. Yes, let's go on. So yes, in fact, I joined Auroville in 31st August 1989, and I started to train people in February 1990. So this is towards the dissemination of earth-based technologies and earth architecture. We have regular courses in Auroville. We have 2 courses for architects, engineers, technicians, students, and masons. We have awareness programs of different topics, long-term internships for architects, engineers, and students. And then we do on-the-job training on different construction sites. Since we train locally people, from masons to architects, to build something. We have also other programs in India and abroad. And we have also the 2 courses and on-the-job training. That's what I was doing in Syria for the last 3 months. So of course, we go to different conferences, congresses, and symposiums. So now I will detail a little bit the different training courses that we give. So we have the production of compressed stabilized blocks, or CSCB. They are open to everyone. So people, they learn in 1 week all the theory of for the soil identification, the soil calculation, stabilization, or the process of block making. And then they have 4 days of practical work to produce blocks. Then we have masonry with CSCB, when they learn some theory, but mostly practical stuff, like the bond pattern here, building some walls, plastering, doing some different techniques, like porous concrete foundation, plasters, composite beams and lintels, and so on. Then we have design with CSCB. This is only for architects, engineers, and students. So people, they have to work on a computer, on AutoCAD. Then we have this resistance. This was, for example, in Haiti in 2010. This was in Auroville for a project for Nepal. So these courses on this resistance are given upon request, because luckily there are not disasters every year or major earthquakes in the world every year. So we just give these courses when people ask for them, like it was the case for Haiti. Then we have theory of arches, vault, and domes, AVD. So we have 1 week for the theory, where people can learn and design some vault and domes either working on computers or on tracing paper or using this kind of boards here. Then we have masonry with arches, vault, and domes, where people enjoy building different types of arches or vaults or domes. Then we have awareness programs, which are given upon request. So this was in Gujarat after the earthquake of 2001. This is in Auroville for different programs that we have. And then we have more and more demand for these training courses. Of course, with COVID, we had a big stop almost for 1.5 years. But now we start again the courses because COVID is recessing, luckily. We start again for the training courses here. And outcome of the training activities. So these are the total classes, soil identification. This was in Gujarat. This is in Auroville. Then again, these are the lectures, bond pattern here. We're doing some rounders walls, rounders foundations, composite techniques like a U-block with concrete inside. So UCSCB with concrete inside. Hello? Yes, I can go on. Then we have outcome of the training activity with arches, vault, and domes. People enjoy a lot the study of the AVD, either by hand on the tracing paper on computers. And then they have, and then you can study that in 1 week. So this can be the result in 1 week work. And then they enjoy a lot building all kind of stuff. So they play a lot. In fact, we teach them how to build the basic shape of arches and bolts and domes. And then they have a lot of fun to do all kind of stuff like this, or close to dome, no, grand dome, sorry, built by a Spanish architect and so on. So they enjoy a lot these kind of things. They have fun with these kind of things here. So playing also with the strength of the arches. So all these blocks are stabilized with 5% cement. So now a small summary, I will go a little fast because this is just numbers. We have trained a lot of people from all over the world. We have in general little more than 1/3 of foreigners coming to India. So we have different type of activities like awareness programs, courses of 1 or 2 weeks, long-term courses, different courses in India, mostly awareness courses and short-term on-the-job training, and outside also. So now this is a flat research that we do with a manual machinery called ORAN that we have developed for building with earth. So we have developed this kind of machineries, 2 types of machines which are manual. peripheral equipment like wheelbarrows and quality control devices run those forms. So this is maybe, yes, I prefer to see it. So here we mix some soil, 200 liters of soil, 30 liters of sand, and some cement, 5% cement by weight. We mix it dry first. So now we add water, mix it again by hand. And then when the mix is ready, we pour it into the press with a scoop, a hand shovel. We slide the hopper. And when the hopper push back, we always level the soil with the same amount of soil into the mold. Then we compress the lid. So we apply here, we have two people pressing the lever to apply a force of 15 tons, 15 tons on the lid. Then there is automatic opening of the lid. And the block is pulled out. So this device is for the strength of the block freshly made. It's called the pocket penetrometer. When you press till this depth here, you have a certain strength given by the spring, and the penetrometer should not go more than 6 mm. So this is the world standard. So if it goes by 6 mm in this level, the block is well compressed. But you can see here that the penetrometer goes by 2 to 3 mm inside, because our machine compresses more than the average. And then after that, the block will be stacked near the machine. So the block will be stacked near the machine and covered with plastic sheets for 2 days, because we should not allow the block to dry. As you have some cement or lime also sometimes, you have to cure the blocks. It means keep them humid for 2 days, and you have to keep the block humid for 4 weeks. But the first 2 days are critical. That's why you have to cover them with a plastic sheet to avoid any evaporation. And after 2 days, the block can be moved outside on wheelbarrows and stacked in a big pile like this and cured for 4 weeks. That means they will be left on the sun and then watered for 4 weeks, 2 or 3 times a day. The principle is that the block must never dry for 4 weeks when you have some cement. If you use lime, it will be slightly different, but you have to cure the blocks also. So these blocks are for earthquake resistance. They're called hollow interlocking blocks. So now we see, yes, maybe, yes, I can see it. So here you have a CSCB and a fire brick, which are produced locally. So you can see the difference. So this block has 5% cement inside. And then we see, no, sorry, I already showed that. So this block is in water for 2 hours only. So IIT is the co-director, he just steps on it because often people, they ask what about the strength when the blocks are wet. So this shows the blocks have 5% cement in water for 2 hours only. Of course, it can withstand the load of IIT, the co-director. But this blocks in water for the 5th of April 1995. This means in water for the last 27 years and 1 month and 1 day today. Always in water. And of course, it can resist the strength, the load of IIT easily. So of course, this is not a scientific test, but it marks the mind of people because it shows them that, okay, this can resist water and it can take some load. If you press this block on the testing machine, it will have a strength of about 3 to 4 megapascal. That means 30 to 40 kilos per centimeter square of crushing strength. So now we see the motorized machines which are developed with the workshop Oreca, because we are in collaboration with Oreca. The workshop manufactures the machines which are manual, and they develop these motorized machines which are crusher here, motorized mixer, and press, hydraulic press. So now we can see the crusher in operation. So this was a prototype machine with the diesel engine. Now we have only electrical motors. You load the crusher with wheelbarrows. So the soil has a lot of lumps, some rocks sometimes. So the helper here helps the loader crush sometimes big lumps. The crusher can break lumps up to 100 mm, even stones of 100 mm, and it will come into dust. This is a result after crushing very fine soil, very fine dust. The soil can be moved by bobcats, or the crusher can be slid away. It can be rolled, it can be pushed on the wheels. So now we see the mixer and the block making with the mixer. So here we have the sand on one side. We put the sand. We have a partition plate here which can control the amount of sand and amount of soil, because most of soils they need to have some sand added to it. Soil on this side. In front, you have the hopper for the cement. In front here, you have, in fact, behind here, there is a vibrator to help the cement flow down. In front, you have a kind of gate to control the amount of cement you want to have in the mix. So here we have 5% cement coming to the soil. Soil is here, sand is just behind. Here, the workers control the water flow. There will be this valve, and the spray will be inside of the mixer here to control the amount of water. At the beginning of the production is the first minutes of the production with the mixer. The mix, sorry, I missed it, or I have to go back, sorry. I missed it. Let me see. Come back a little bit. Yes, in the first minute of the mixer running, the mix here is either too dry or too wet. That's why the worker here, the operator, checks that the moisture content is correct. And this one will not be wasted. It will be put back at the beginning of the mixer. It will be poured slowly into the mixer. So now the mix is okay, the moisture content is fine, and this goes to the press. And the helper here takes back the first mix and put it back slowly into the mixer. So this is a continuous mixer, which gives a really high output. And then the press here. This was a prototype machine. The machine has evolved a lot. This was the first machine done in 2014, I think. So we have here manual closing of the lid. So you see the operator close the lid manually, operates one valve to compress, automatic opening, push the hopper to push the block. The speed of the machine is given by the speed of the operator. So this is something which was important for me, which was developing motorized machines to have a better output per day and work much easier for the workers, because when you press by hand the blocks, it's really hard job. So here, for this team with the crusher, mixer, and press, we still have between 18 to 22 people, depending on the type of block yard. But you have every day more than 2,500 blocks per day. So now we have to control for the quality. Again, the penetrometer, you see it goes very little inside because the block are stronger with the motorized machine than by hand. So now we stack the blocks on pallet, then we remove the pallet on the side. So this means that you should have enough investment on the side to have pallet, pallet jack, and forklift, which is the best in fact for the production. After we have the pallet wrapped with a cling film to allow the block to be cured properly, and also to be moved easily without the pallet opening and breaking down. So here we put some extra water to have more water for the curing, because we don't put water. As we have the clean film, we don't have to cure the blocks like watering like we did for the pile outside of under the sun. That's why we have here covered with clean film, and we don't cure after for 1 month. And so now the pile is ready to be moved outside. And if you don't have pallet jack, and forklift, you can stack on the ground with the workers. You need more workers for this process. And sometimes you may have to stop the machine to move the blocks. It's always to find the optimum investment for the machinery and the manpower on site. So now we're seeing the different things on the compressed stabilized box. The machine, the Armpress 3000. So it's composed of soil, cement, often 5%. It can also be lime, and often you have to add some sand, and then you press it. And then we have here, they are compressed either manually or with a motorized machine, like you have seen. They don't require a lot of energy. They're not fired. That means they emit much less than the carbon, much less emissions compared to what we call country fabrics. You will see after some photos of that. So embodied energy will be little also. You will see that later. And you can use CSCB for all kinds of masonry, for the walls, columns, arches, vault, and domes. And it is a very labor valorizing technology because you have a lot of people to work. 11 to 13 on a manual machine with this kind of output per day, or 20 to 22 with a motorized machine with this kind of output per day. And this gives job opportunities and livelihood to people. And after that, the block will be cured for 28 days. And they will have an average strength of this in Auroville. I will go a little faster because after we have a full lecture on CSCB. So yes, we do a lot of research on the type of blocks. We have here about 70 different blocks produced with one machine. So we have energy efficiency. We have about 10.7 times less embodied energy than the country fabrics in India. Then we have carbon emission 11.8 times less. If you compare to concrete blocks, it will be about 4 to 5 times less. If you compare with reinforced concrete, it will be about 8 times less. So this limits deforestation because we don't need firewood to produce CSCB. The main source of energy is coming from cement or lime. Lime will produce less carbon emissions also. Example, this is what they do in Tamil Nadu in India. They burn 50 tons of wood for 100,000 bricks. And they burn a lot of wood for that. So we have this resistance. We use rust masonry, which is reinforced for the earthquake resistance. This house was built in 66 hours in Delhi as a demonstration. This one was built in 62 hours in Gujarat. In fact, both houses have been precast in Auroville, transported to Delhi, transported to Gujarat, the north of India, and assembled in less than a week. And this was built in Istanbul for the seismic habitat in 8 days. And this one has a dome. There's a square dome here. And this was built in Tamil Nadu after the tsunami of 2004. So we have government approval with this technique from first Gujarat in India after the earthquake of Kutch in 2001. Then the government of Iran after the earthquake of Bam in 2003. And then finally from the government of Tamil Nadu in India after the tsunami of 2004. So this is the result of the work that we did in Gujarat. In fact, we have assisted the Catholic Relief Services to build in about 1 year 2,688 houses in 13 villages, employing 2,000 people. In fact, ourselves, we have worked maximum maybe 6 months in Gujarat to give some training courses to evaluate their work, guide them, and this was the result of their work. So now we see different building techniques, which is with here have composite columns, stabilized waterproofing, stabilized rounders here, stabilized rounders foundations, and composite beams. That means a U-block with CSCB with reinforced concrete inside. You cannot break this beam. There was not even a crack in the beam here. So research on ashes, vault, and domes. We do a lot of research on that. So different vaults, like a dome of 22.16 meter diameter, built in 9 weeks. This is my living room here. So wall consultancy, we have been working in 38 countries all over the world. And then wall consultancy, again, this was in Agebam after the strike of 2003. In Libya, after the, in fact, this was for the restoration of Ghanames in Libya. And then a little bit of heritage conservation to restore a temple in the Himalayas, a Buddhist temple of the 12th century, which was in a bad state because of the leakage of the roof. So now we see different buildings in India. I will go a little faster because we'll see more in the next presentation. I will show more. I will go a little faster for that. So this is a building done in 9 weeks, a dome of 22.16 meter diameter. So Al-Mehdi Mosque built in the heart of Riyadh in 7 weeks. And then Kazakh Center in Spiti in Himachal Pradesh, in the north of India, very close to the Tibetan border, in fact, Chinese border, but Tibet is just behind here, or China. And this was built in 2015, finished 2015. It's a spark-resistant building, solar passive heating with a trombe wall and ramdos walls. And we don't have any other heating than the sun. A very effective system we had in winter, March 2019, outside temperatures minus 22 degrees Celsius, inside plus 10 in this room here. So this is one of the last works that we have done with a big vault of 50 meter diameter, 50 meter span in Pondicherry. And I finish with this quotation from Assad. I don't see the earth as a formless material without consciousness, but a spirit consciously disguised as matter. So I finish with this presentation. If you have any questions, maybe.
I believe we already have the first question, Mr. Satprem. The question is from Mrs. Caterina Ventrugno, and her question is, what are the biggest challenges using these materials?
Yes, the biggest challenge in fact to convince people, because it has a lot of advantages. It can be cheaper, it's much more eco-friendly than something else. But the main problem is how to convince people to use it. Because you still have, in the mind of people, the negative impression that Earth is not strong, it's not good, it's not for the poor. And you will see after some buildings which are not totally for the poor. And the main problem for me is how to convince people to use this technique.
Thank you very much. We have another question from Mr. Joaquin Luciano. He's asking, what is the process for the columns as structural elements?
In fact, for the columns, yes, there was just a small photo in the corner of the slide. We use composite columns, which are made of CSCB, round shape with CSCB, which is hollow, and we reinforce it with some steel bars and concrete. And we have two types of columns, one which is 240 mm diameter with a hole in the center, and we have a bigger column with 290 mm diameter, which is reinforced with 4 bars. And in general, we can have 3 meters can be built in 2 days for these columns, and it is just taking time to build it, but you don't need any concrete form. And the column can take a lot of weight. We have built a column like this, which was taking about 1.2 megapascal of pressure. And it is there for the last 27 years.
Thank you very much. Yeah.
Yes.
We have if anybody has any follow-up questions regarding your, well, already proposed questions, please let us know in the chat too. Mrs. Julia Guzman is asking, if someone did a training with Auroville Earth Institute and we are convinced about the technique, how do we implement it in our country? Would we buy the machinery, like the Aurum Press 3000, for example?
Yes, in fact, yes, we'll have to buy some machinery. Well, you can buy our machine. You have many other machines worldwide. And so, of course, we train people how to use our machine, but you can use whatever machine you want later. So basically, yes, you can get trained here. You can buy some machinery from us. We can assist you for different parts of the project if you need. And we can help you later if you want to have some assistance for advisors on evaluation missions sometimes. We can do that. We have done that all over the world.
Okay, perfect. Thank you very much. Are there any further questions? Okay, architecture. Mikauli Martinez is asking, what can you say about the rentability for a project using this material?
Rentability means to have some profit made, you mean?
Indeed, I believe
yes,
so. Yes,
I would say yes. In fact, our center is not meant, we are not a production center to make blocks and to sell blocks. We are researching the technique, we are training people on how to use it. But I know that several companies in India they are producing blocks with our machine or with different machines, and they're making some money. So, in fact, I would say with all the economic analysis we do for this CSCB, it can be a profitable system. That means, but what we try to do ourselves for how to promote this kind of company is to have a social business. That means to have a business which is meant for social objective. That means whatever profit you make, for this is our approach if I had to do this kind of business, is that whatever profit you make from the company is coming back to the community in terms of better outreach, better development, better product at a cheaper price. But the business of block making can be profitable if you have 2 machines. If you have only one manual machine, the overhead of the block yard with 1 machine will be too high. You can start to make some profit if you have 2 machines. And this is possible. So maybe I should ask maybe that we can go on for the discussions after, because I have one more slideshow which has many more information about the CSCB, and I'm sure that the same question will come back or more will come also. So I propose that we start for the questions now, and I will share the new slideshow on the CSCB for the sustainable future.
Perfect. There is one last question which I believe could be answered really quickly.
Yes.
And from Joaquin Luciano, and he says, have you published any book on the subject? And if you have, where can we buy it?
Working with?
Purchase it.
Yes, in fact, yes, we have, yes, as I mentioned in the first slide, we have published, in fact, we have done, in fact, we sell 22 publications presently of different sizes. We have a different series of publications. Some are very little ones, like what, 10, 20 pages, which are just a small introduction to some technique. And others are training manuals, which are from what, 130 to 229 pages. And we have a training manual on what we call Code of Practice of CSCB, and then which is, I think, 132 pages. We have the training manual on Ashes Vault and Domes, which is 229 pages with a few hundreds of illustrations and diagrams. And we have as a case studies also on earthquake resistance on different houses we have built. So this can be purchased by us from us. So we can either send them as a PDF if you want, or you can send a hard copy if you want. Just have to contact us. So in fact, after you can share our data to everyone, that they can contact us if you want. And tomorrow I will send you also the PDF of all the presentations that you can share with people. That means they will have also a PDF version of the presentations that they can access later.
Perfect. Thank you very much, Mr. Satprem. I am sorry to have proposed one more question because it was actually the first question proposed, but it was at the beginning of the conference.
Okay.
And it's Mr. Alejandro. He says, greetings from Quito, Ecuador. Can you give me the name of the person or company or organization that represents you locally? I believe it's in Ecuador. I would be interested in contacting them.
No, I don't have any contact in Ecuador. No, I'm sorry. We don't have any representation elsewhere. No, I'm sorry. We are working from India, and I have to travel a lot to do different things, but I don't have any contact at all with Ecuador. I'm sorry.
Thank you very much.
So shall we go for the next presentation? So this is a more detailed development on the compressed stabilized blocks. We'll see this in the lecture. Then we have Earth architecture in the world with a small introduction of what happened all over the world since millennia. Introduction a bit more than what we had on CSCV. The results, maybe I will pass because there is an overlap between both. And then selected projects that we have done and different buildings that we have done worldwide and some data on Earth architecture. So this is something that is like a lot. Mondo cities are looking all the same. This is Cairo. It can be the suburb of Chennai or Delhi. This is New York. It can be the same like Mumbai or Delhi also, or I'm sure as you see like in France, Paris, and so on. And this is Boston City Hall, which was built in 1968. A lot of concrete here. How many tons of concrete inside this building? How much initial avoided energy inside? And how much carbon emissions? So now there was a proposal for the rehabilitation of this building with even more energy hoggy materials and technologies with a lot of steel, glass, aluminum, even worse than before. So I will have to mention here what is initial embodied energy in buildings. It is of course, people are not often aware of it. So this is what we have. It's a non-renewable energy consumed for the production from the acquisition of the raw material, their processing, manufacturing to transportation to the site. It is a very good indicator for the overall environmental impact of buildings. And important to know, the embodied energy of a building can be about 30% of the total energy consumed for the building during its lifetime. So this is not small amounts. And now we have the recurring embodied energy, which is energy consumed to maintain, repair, restore, and refurbish or replace materials during the lifetime of the building. Operating energy, which is energy required to use the building for heating, cooling, ventilation, and so on. And now we have different materials data on this. Aluminum very high. In fact, often these numbers that don't give any idea of what it is, but you have to compare the results. Aluminum, steel, toughened glass, country bricks in India, reinforced concrete, then concrete and CSCV. So you have to relate this amount to see the ratio that you have between these two. And that's often what I criticize a lot from the green buildings. like the LEED buildings and so on, the platinum buildings and so on from LEED, they deal only with operating energy. They don't deal with embodied energy. And they use a lot of aluminum, steel, and Teflon glass and so on. So example of this one in Israel. This is LEED platinum. So they have nothing green. They just consume less energy for operating the building, but how much energy goes into this aluminum, glass, and so on. Example also of the concrete industry in buildings. Cities take about 2% of the Earth's surface, but they consume 75% of the natural resources. Construction sector is responsible for 40% of the consumer resources, 40% of CO2 emissions, and 40% of waste. And the buildings account for 30 to 40% of the total global energy usage. So again, the same deal, 1 ton of Portland cement is about 0.95 tons of CO2 emissions. 1 ton of concrete emits 0.107 ton. Cement accounts for about 5% of global emissions, some even say 7 to 9%. Now, these are not small amounts. So example in India, with the country fabrics, they have this kind of production. This was in the past, this is today. So wood composition is quite carbon emission. You can see this. That means from 1 kilo of wood, you have this much of emissions. It's quite incredible. And then you have this in India. So in the north of India, they burn mostly with the coal. It is even worse because you have this kind of production in India. India is the second largest producer of fabrics, 13% just behind China. They have 30 million tons of coal burnt per year. And you have this. It's beyond imagination. So now about sustainability. This is the definition from the World Commission. I will just let you read it. And another definition from the wisdom from the past from Kenya. No, this is, no, in fact, I passed this one. This is from the Ivasaya Upanishad from India. Very old text, which is maybe what, thousands of years old. All in this manifested world consisting of moving and non-moving are governed by the Lord. Use its restraints with use its resources with restraint. Do not grab the property of others, distant and yet to come. So this speaks of two things. First, management of resources, but also equity and honesty. This we miss really in the world today. And then from the Kenyan proverb, treat the earth well. It was not given to you by your parents, it was loaned to you by your children. So this is the same definition of that, I would say. Just said in a different way, but this leads to that. That's why we have to be careful with what we do with resources. So we see three dimensions of sustainability, which is first social, to uplift the local skills and empower people. Then environmental, which is to use the resources which are local in a proper way. And then economic, to promote endogenous growth. That means local growth. So as examples of earth construction worldwide, this is a photo where you have earth buildings all over the world. The dots here are the UNESCO World Heritage Site. You have, this is from UNHCR Habitat. You have 50% of the world population living in earthen dwellings. 25% of the world population does not have access to decent housing. And UNESCO states that you have 17% of the world cultural heritage is built with earth. 25% of the world heritage is in danger with earth. And 40% of the 100 most endangered sites is also built with earth. Examples of the buildings with earth in the world. This is Syria, in Mari in Syria, about 2800 BC. This city was destroyed soon after. I think it went 1470 BC and covered by the rivers. So this was the adobe walls below and covered by the rivers, by the rivers. Ramesseum in Egypt, still standing after 3,300 years, more or less. Yemen, in Sanaa in Yemen, Shibam, the Manhattan of the desert, and different buildings in India, in Morocco. So now we see a CICD more in detail. We have 5% cement in general with soil and sand and water, compressed in a press, manual or motorized. They can reach in Auroville a compressive strength dry of 9 megapascal. Often you have 6.5 as an average here. Wet strength will be a little less, like 4 megapascal. We never use the topsoil. Topsoil is always removed. Topsoil will be kept for landscaping later. So we take always the subsoil below the topsoil. They are used on all continents. And they have been, for me, a major tool of the renaissance of horticulture worldwide since the 1950s. And it is today the technology used the most in worldwide and also in Auroville. So the first press for block making was the Sinvaram, developed in Colombia in the 1950s. This press has been used a lot, copied a lot, and you can find on the online some plans for it. And we became one of the leaders of this technology. And we have a full range of equipment like we have seen before. And we have a machine 3000 can do about 80 blocks with a deep 20 moles with a very high precision, up to 1 millimeter difference in thickness. So this is a machine which we produce, in fact, a few machines produced worldwide. The Sinvaram from Colombia, machine from Europe, from India. This is Oram from Auroville. This is from Belgium. This is from Motors machine from France, USA, other forms from South Africa. So now some data. We have dry composite strength. It varies from 5 to 9 megapascal. As an average 6.5 in Auroville. Wet composite strength will be much less, 3 to 4 megapascal. That's why you need to know always the wet composite strength, which is the minimum strength for the blocks, for the compression strength, to use it. Then you have dry bending, which is much less, 0.5 to 1 megapascal, but you don't have bending in a building normally. And shear is the minimum strength, 0.4 to 0.6 megapascal. And shear can be avoided with a good design. And then water absorption between 8 to 12%. Apparent bulk density, an average of 1,900 kilos per cubic meter in Auroville. Embodied energy, like we have seen, 10.7 times less than concrete for bricks. Carbon emission, 11.8 times less. So this is to remember what is MPA, in case you forgot, so you don't know. This is for Auroville soil after 28 hours of curing. And these mechanical characteristics are influenced by different factors. First, the soil quality, then the compression ratio, that means how much the machine can compress, the force applied by the press, the quality of manufacturing, especially the curing, and of course, the quality and percentage of stabilizer. So we have, in fact, we have a few standards. I just mentioned mostly the Indian standards here, standards related to the Asian side. So this is from the Gujarat after the squat of Kutch in 2001. This is the Indian standard for what they call stabilized salt blocks, which is in fact CSCB. This is Indian standard. We have the standard, this is from the Sri Lankan standard, which has meant this standard as compressed stabilized earth blocks, requirements and masonry after on building. And then you have also some codes in Nepal based on our works. And then now we see, well, I will pass because in fact I should have removed this. I will just pass this one. This we have seen. So this is the machinery that you have seen. Some views of the blocks. In fact, we have here a few blocks, but basically what we have is solid blocks as a square here with full size, 3/4 and half size, or rectangular size, full size, 3/4 and half size, because each mold can make full 3/4 and half size. Then you have hollow blocks, again square or rectangular here. Then you have hollow interlocking blocks for this resistance. We have special blocks that are woody for floors and roofs. Then we have round block for columns. So this is 240 mm diameter. This is 290 mm diameter. And then we have special blocks, including tiles and U blocks for the ring beams, and mini blocks like this for vault and domes. So this you have seen, I will pass. This you have seen also, you have seen that. So reinforced masonry now, we have seen this. So I did not notice here, I did not know that, but what we do here, we have vertical reinforcement in the corners of the building at different lengths, different intervals in the length of the building. And then the blocks are hollow interlocking blocks. That means they have a key here, which can interlock. So both these buildings have been precast in Auroville, transported to their place in trucks, and built in a very short time. So this you have seen. So then government approval, I will come back on that because first we had approval to build two floors in Gujarat. And basically they have approved the strength of the block, because the blocks are strong enough to take the earthquake stress. And we add also extra strength from our design for the reinforcement of the blocks with the different vertical bars and horizontal bars. And then Iran the same, and Gujarat and Tsunami for the Tamil Nadu government. So you will have this kind of books. You have, this is the production of use and use of CSCB, the code of practice that you have published. Yes, 136 pages. We have also earthquake resistance manual. This is for architects and engineers. We have also the building with ashes vault and domes. In fact, this has been updated last year. It's 229 pages with more than 400 illustrations. I have to correct that. And then work specification, which is a document which summarizes all the different ratios and research we have done on different techniques with the mix first for different soil mixers, soil stabilized mixers, even concrete and so on. This can be purchased from us. So now we see some examples of projects that we have built in Auroville. This is a visitor center which got this award in 1992. It was built from 89. In fact, we started the building in September 1999 and finished in 92, February 92. This is our office. It was developed over the years. From here, this was done in 1999. 1989, sorry. 1999 to 1990. This was my room above, my living room built in 2000. And then we developed this later in 2008. Shakti High School in Pondicherry, which has been built for 1,800 children for day and night classes. The school is used from 9 a.m. to 10 p.m. Children are coming at night to work on learn some carpentry and do other stuff. Vikas apartments built on 2 floors first. This was the first phase of Vikas on 2 floors. Dipanam and Miromais school built with stabilized rounders and CSCB domes. So here you have a square dome. You have a square dome below here. The vault of Dipanam school, 10.35 meters span, built in 3 weeks. With this team, here you had 4 masons and workers to build the vault. Very thin vault, 17.7 centimeters at the bottom, 40 centimeters from here to here. Physical apartments built on 4 floors. You have here a basement floor and then 3 floors above. Because basically what we did here was to take the earth from the basement to build the blocks and then build the building with them. The Dhananga temple built, in fact, it's built with fabrics. Unfortunately, it was not built with CSCB because we had a lot of constraints for the set schedule and to speed the work, so we had to use fabrics for that. But the dome was built in 9 weeks. In fact, in between end of the year and next year, I will have to build a bigger dome than that, 33 meters diameter in Gujarat, and this time it will be with CSCB. So 1.5 times bigger than that will be built next year in Gujarat, north of India. So this is inside the dome after 9 weeks. A small house done with a mix of CSCB and straw bale. You have here CSCB walls and CSCB columns, and straw bale here and here, plastered with lime stabilized earth plaster. This is my living room above the office. This is the house built in Gujarat after the squawk. This was the starting point of the revolution in Gujarat. The house was precast in Auroville in about 3 weeks, transported in 3 trucks to Gujarat, and built in this time, 62 hours. And after that time, the house was usable. There was light to the bulbs, everything was painted, there was water running to the tap, everything was functional after 1 week of work in situ. Small buildings in Auroville with rounders, stabilized rounders with CSCB vault and dome. Another building called Gayatri Dome, built in the years 2003-2004. Al-Mini Mosque built in Riyadh in 7 weeks. This was a big challenge for us because we had no time to build this mosque. So, for example, this was after, in fact, I cannot have time to show the photos of the details of the site, but it was 7 weeks after for the road construction. And then the contractor took 7 months to complete the building for the finishes inside. Then Shri Kaneshwar Nataraja temple near Auroville, which is for Lord Shiva Nataraja. Inside the dome, a very small temple, 6 by 6 meters square, with a pointed dome like this here. A school and community center near Auroville. So we have here what we call ferrocement channels that we use a lot with vault and domes. You have a square dome here, 7.5 meters span square with ferrocement channels. And then a project which is very dear to my heart because this was built in Nepal in 20 days. In fact, I trained one architect, one engineer and one technician from Nepal. They came here for a training course. They went back to Nepal to train their team of workers and masons. Then I went there to assist them to build it. And in 20 days, in fact, foundation was done before. Also, superstructure was done in 20 days. From here to here, 20 days. In blue, you have the volunteers from the village. That means you had, I remember there was maybe a grandpa of maybe 70 years old and children like what, 7 to 10 years old, because they wanted to build their own school. And in red, you have the paid masons. And what was very good was not just the time to build the school, but the project went ahead The same team of masons went into different villages after to build again different schools in the same time. And they could manage without my help to build schools in about 20 days. And this is 2 classrooms for 100 square meters of building. And this building has resisted the quake of 2015 in Nepal. Then we go to Himachal Pradesh in India for the Spiti Kazakh Community Center in Spiti, which has got this award at Marrakesh in 2016. Healthier apartments on 2 and 3 floors. You have apartments here, 2 floors here, 3 floors here, with lamp stabilizers, plasters on the facade here. Sharanam Rural Development Center in Pondicherry, with dormitories here. This is for the training center. So these are accommodation for the training center with 2 floors building, 1 floor building here. And then the vault of the multipurpose hall with 15-meter span, 1 5-meter span, built in about 5 weeks. So this is how it is built. So we don't use any formwork for that. You can see here we have a template. The template gives just a shape, and then we have to put some string lines. Of course, I cannot show the whole process of the construction, but the whole construction was built without any formwork. We just move the template time to time to put the string lines. We have a conical shape here. So the mason sticks the blocks onto the previous course with just earth mortar. In fact, the glue, because it's a glue. You see, he just laid some stabilizer mortar on the block and lays the block. So here the mason grinds some block to have a smooth finish for the next course. If there is any irregularity in the thickness of the blocks. You see the mason here just slides the blocks up and down after putting mortar. It just takes what, maximum 5 seconds to lay the block, and then you go on. So we have here a 15-meter span, one 5-meter span. And we have here a conical shape starting here at 6.61 meter span, then rising up to 15-meter span, and then the barrel part here of 15-meter span also. And we kept here a gap here for the skylight and for the ventilation of the room. So you can see here the steps that we have because of the conical shape of the wall. And this is very good for the acoustic, because this minimizes the echo and the reverberation. Okay, so this building, before it was, in fact, before the finishes were done, this was a just raw construction. So now I will show some photos of different examples of what other people did. So this is a Chitra Vishwanath in India. So this will be examples done by different architects in different parts of the world. So this is in India by Chitra Vishwanath. In Bangladesh by Ketisha. So this is in France from a local architect in the mountains. But as you can see, you have two different styles of architecture. This is a flat roof terrace from Bangladesh, like here in Bangalore, or like this in the Alps in France. you can really adapt the answer to the climate. So this is in Mopti. In fact, Francis Kéré just got recently the Pritzker Prize of Architecture for all these works with CSB in Africa. Great architect, Francis Kéré. Then the Mayotte Airport. Mayotte is a small French island between Madagascar and Kenya. Airport. The prefecture of Mayotte also. Apartments in Mayotte. Then in South Korea. So now we'll see some data on Earth architecture. Hydrothermal behavior. So here we mention the name hydrothermal because the Earth has a different behavior with the thermic than other materials. They have hydrothermal with water. I will explain it because exposed rocks have different behavior than other materials because clay is stabilized and not burnt. That means the clay can still absorb moisture and release moisture. So when the Earth will absorb water, it will condense, it will create heat. And when the block evaporates, it will cool down the building. So this is called latent heat. It is constant migration of water, of moisture through the wall can either cool down the building by evaporation and heat the building by condensation. And this can be an enormous amount of energy that the building can create. So what will happen when you have the outside temperature is higher, the wall evaporates moisture. So the building will cool down. When it is lower outside, the wall will condense moisture, and this will create heat. That's why this is more effective in temperate climates than tropical climates. And there is a word in France which says that in the countryside, people say that rounded buildings are hot in winter and cool in summer because of this latent heat. And in the Himalayas, it's the same. It can really regulate a lot the temperature of the building. And we don't need any air conditioning. Especially in Tamil Nadu, as we have a very hot tropical monsoon climate. So now we have about 36, 38 degrees these days, with humidity between 55 and 65% these days. So really hot and humid. And we have a lot of ventilation in the buildings, natural ventilation. And that means we need much less operating energy to work with the building. So they're cost effective and they can help a local economy. So what we call by cost effective is to spend the minimum amount of money for the best use of it and to spend the money locally. So today, this is for Auroville. The CSB are closer than country fabrics in Auroville. They were 10% cheaper in 2011. And in fact, the market in Pondicherry area, because we are close from Pondicherry, it's a bit crazy. And we can compare, in fact, the cost of the raw material of CSB and country fabrics, because the blocks are bigger than the bricks. So these are the costs that we have these days between CIB is country fabrics and CSCB. And when we compare the cost, we're 8% closer today. And one of the reasons is that the country fabrics are produced often by bonded labor. That means bonded labor means slaves. It means the labor is bonded to the employer by different pressures of money and they are done to work. And then they can't escape. And that means we cannot compare the cost of our blocks and the cost of the fabrics because our workers, they have all social insurance. In fact, we have different terms for that in India, but let's say the social security system in India, which costs us 33.6% of the salary. Of course, this cost has to be added to the cost of the blocks when the bonded labor has nothing. It's just like a slave. That's why we cannot compare the cost, in fact, because of that. But when you compare now the cost per square meter or cubic meter of masonry, that means the wall, then we are cheaper. 16% cheaper per square meter of wall, and 26% cheaper per finished cubic meter of wall. And why? Because we have much less mortar required. 15 to 60% of mortar less required. The mortar is stabilized earth. It means it is much cheaper because you have less cement inside. And we don't need plaster in most of cases. If we use plaster, we use lime, not cement. And we don't need concrete frame. That means you can save a lot of money on the whole system. So it is very labor polarizing technology. As I said, you have 30 people per press for the manual pressing. This gives job opportunity to people. And of course, livelihood. This can ensure sustainability for the place. And cost breaker for CSCB, this was last year. So let's say about 6 months ago, more or less. So we have here the different costs. Labor is about 30% of the blocks. Salts and water materials about 40%. Cement about 15.4%. And equipment about 8.4%. And what is important is to remember that the main cost of the block goes to labor. You see, you have, in fact, you have all of these, or you have also salts and cement. But if you compare to concrete, you have opposite ratios. I will mention that for the building which is finished. When you have especially vault and domes, the labor represents 60 to 65% of the building cost. Of course, material is the opposite. If you have a concrete building, it is just the opposite. You have about 60 to 65% of material cost, and the rest goes to labor. That's why what is happening here, the money stays locally with people who work in the villages around Auroville. So examples of the management of resources, we have just different photos of the same thing. You have here basement floor, wastewater system here, rainwater harvesting systems, and so on. So local authorities can manage people their own resources. Quarries resulting from the sources of soil can be used for different things like you have seen, from underground rainwater harvesting tanks, reservoirs, surface rainwater, landscaping features, wastewater systems, basement floor, and so on. It can be very beneficial for the development if it's well planned, but very disastrous if you don't do it. That's why you have always to plan in advance what the whole can become later to use for the development of the place. That's why you have to make a plan before and do it after the quarry is done. So now we finish with these emissions of carbon dioxide. So this you have here 11.8 times less than construction bricks. And then, in fact, CSCB carbon emissions are produced in CSCB are the lowest, and it comes mostly from cement. Finishable about energy in the same range. We don't require firing for the blocks. We have 10.7 times less. So yes, I come back on that because this is important to remember this. And compared to the fabrics. Examples now of the residential apartments in Auroville, which were built in 3 blocks. We have here CSCB and stabilized earth from the foundation to roof, rainwater harvesting systems, wastewater system for the water treatment, earth tunnel for the municipal air conditioning, initial embodied energy was about 4 times less than a normal building, like concrete frame and concrete RCC is for reinforced cement concrete, and if we use fabrics, operating energy much less, 3 times less. And I finish with that. You have seen that, and have finished. So if you have any questions, maybe. So no questions if you have.
Yes, please write your questions in the chat box. Convey them to Mr. Satprem. Oh, Mr. Satprem.
Yes, right, yes.
Jose Enrique del Monte, who is a specialist in patrimony, wrote that on the world map, we did not see Santo Domingo among the UNESCO World Heritage Sites.
I don't know if there was any site in Santo Domingo. I don't know, honestly.
Actually, we have the colonial zone.
Yeah, but was it a building made of earth?
Well, I believe maybe Jose can confirm that information. It is duly inscribed.
It is what? It is
duly inscribed in the UNESCO World Heritage Sites. It is their only, I believe, heritage site, the colonial city of Santo Domingo.
I think the map is old. That's why it's not there, because it has been recognized later.
Okay, perfect.
Yeah, in fact, the thing is, because this map is done by Crater. Crater are my friends from France. Crater is the International Center for Architecture in France. So they have done this map, which was a thing from 2010. This piece is already 12 years old. So maybe there is a new site, but this is only for the house buildings. So unless there is, maybe there are some house buildings in this site, I don't know, but maybe there is, but I don't have this information.
You know, Dominican architects are very proud of the colonial city. So
yes.
Oh, we should continue with the question. Mrs. Josefina Baez will asking, would you expand on soil quality, please?
Yes, in fact, the soils, yes, the soil for CRCB are rather sandy soils. That means they should contain more sand than clay. In general, we say that the good soil for CRCB has about 15%, 15% of gravel. It's good to have some gravel in the soil. 50%, 50 of sand. Then silt, 15%. Silt is the size between the sand and the clay. So 15% of silt and 20% only of clay. So often you don't have such a soil. Often you have to modify the soil either by sieving it to remove some lumps or to remove some gravel. You have often to add some sand because often the soils are too clayey. So often you have to add what, maybe 10 to 25% of sand or more. And this is the principle. And then the soil can be stabilized either with cement or lime or different chemicals for the water resistance.
Okay, perfect. Thank you, Ms. Josefina Baez. I should continue with the question of Mrs. Caterina Ventruño. I hope I'm pronouncing that correctly. And would you like to propose your question directly, Ms. Caterina?
Yes, thank you. My question is like, what would be the initial investment? So if I start building tomorrow, how much would I spend in machines, for example, to press and to mix and this kind of like initial investment?
Okay, yeah, in fact, I don't remember the price of the machine, but in fact, I designed the machine which are manual and they are sold by a workshop worker. Let me check which is the price. I don't have this kind of data in mind. Just a minute, I'll just check that quickly. So for the manual machines, yes. In fact, the thing is, as we have many molds which can fit on these manual machines, the cost of the mold can vary a lot. And in fact, you don't need to have all the molds. I would say for the blocks that we use the most in India, which is the block 240, which is 240 mm by 240 mm by 90 mm high, So you will need to have with the machine itself, the machine will be total, let's just calculate quickly the thing, plus 1 mole. Yes, only one machine with 1 mole will be around $3,000. And you can buy accessories if you want, like the wheelbarrows and quality control devices. But basically, with about $3,000, of course, with the shipment after to your place, you can have a machine with 1 mole. The mole that we use the most in Auroville. And if you want to go for the motorized machines, it's a different business. In fact, I will not propose motorized machines unless you have a big project or unless you want really to have a business producing a lot of blocks. Because if you want to have motorized machines, what's happening here, you need to have the 3 machines, the crusher, the mixer, and the press. And this is almost 10 times more. Yes, I can just see, yes, it's about 10 times more. That's why if you want to start something, that's why I would propose if you want to do something in your country, start small with small machines, see how it is locally, how people accept the building material, how you can build with that. And the demand increase, then you can go for motorized machines.
Okay, she says thank you. It seems that she had her question is answered. Mr. Joaquin Luciano is asking, how long does it take for a community not familiar with the system to successfully build a regular house after some training? What is the usual training timeline for this purpose?
Yes, in fact, the training course that you give, you have 1 week of production of CSCB, then 1 week of masonry. And if people that want to use Volton domes, they have also 1 week of theory of Achilles Volton domes, 1 week of masonry with Achilles Volton domes. And in fact, I can quote the example from Nepal and another one from, it was in Gambia. So yes, Gambia. So in Nepal, I trained 1 technician and 1 engineer here 1 week for the production of blocks. And then they went back to Nepal, they trained their own people, and then they have produced all the blocks themselves, they have produced all the ferrocement channels themselves, and I just went there to assist them for the construction and to speed up the construction. And after that, the same team of masons who were trained by the technician and the engineer, they went ahead to build more schools in different villages in the same record time. In Gambia, I have trained 2 engineers for the design. In fact, they were trained 1 month in Auroville, 2 weeks for the CSCB production and CSCB masonry, 2 weeks for the theory of arches, Volton domes, and 2 weeks for the building of AVEI. They went back to Gambia, set up their enterprise, and they are building schools and resorts and houses, and with all with Volton domes, and they're really doing excellent work. That's why. But also I have counterexamples when we have trained people who did not learn properly the things, they made a lot of mistakes, and then the project went nowhere. I can really quote as a very successful project like these 2 in Nepal and in Gambia, but I have examples where people totally failed after the training course. And this is depending always on the people, and especially the framework of the project. Like in Nepal, it was really successful because it was a community-based organization who wanted to have this program done, and they followed the project after. That's why after the training course we give them here and in Nepal, they could go ahead and do the school building. In Gambia, it was a local enterprise, and of course they were interested for the business to make from that. And that's why the success depends a lot on the framework of the project behind. Means you have to assist people and you have to monitor well the process after the training course is given.
Thank you very much. Was that satisfactory, Joaquin? He says, excellent, thank you. Any further questions?
Yes, I have 2 questions. One is, what is the cost of the training? And the second one is, what is the cost of the training?
Okay, any further questions?
Well, while more questions come in, Satprem, I have a question more about the, let's say, the history of the Auroville Earth Institute. I mean, what were, in your opinion, the particular conditions in Auroville that allowed for the institute to be developed there, and you know, to become the success it's been? Was it because in India and in the south of India there's particular heritage of building with earth? Was it because of the support of the government? You mentioned it was founded under HOTCO, or was it the community spirit of Auroville? I mean, the community. What is, in your opinion, that has enabled the Earth Institute to grow and flourish?
Yes, in fact, I would say first the help from the government from HOTCO was just initial grant, which was what 350,000 rupees in 1989, which was not much at that time, and all the rest is our hard work. In fact, in Auroville at the time there was quite some demand for alternative materials and technologies, so especially CSCB, and that's why we have developed a lot of this technique in Auroville. From 1999, I would say I have had a lot of work from 1989 to 1998. Then the request slowed down in 1998. Then we had again some projects done in 2008 to 2012. And in fact, unfortunately, I don't have any project in Auroville for the last 10 years. And why? Because people, they want to build their comfortable life with concrete and steel and glass and all nonsense of materials, because there is, I would say, there is some problems in Auroville. There's a amount of people who are supposed to do a lot of research on materials and techniques. We are supposed also to do a lot of research on fertility and the aims given by Shumendo and the mother. But in terms of development, since 10 years, developments in Auroville are totally conventional. And this is crazy for me because I'm requested to go all over the world. You see, I go to Mauritania end of June. I have a project there for a big project for a mosque and so on. But in Auroville, I have nothing for the last 10 years. And this is, I would say, Auroville is in a difficult situation these days. I cannot mention really what's happening, but we have a lot of tensions in Auroville related to the development of the city. And it is, for me, going in the wrong direction. That means with conversion techniques, with concrete, glass, and so on, totally unconventional. And I would say our success just because of our hard work. That's all. And also because there was at the time in Auroville the need for that. And today, people, they forget and they don't want and don't do what. And that's why I work elsewhere.
Thanks.
Thank you very much, Ambassador. Miss Caterina Vetruño has another question. She would like to know, what is the estimate lifetime of a building entirely built with CSEB?
Yes, this is a difficult question because the oldest buildings that you have with CSEB are more or less 70 years old. Because I started to build that in the 1950s. I don't know how the buildings are today, but I can tell you that how our buildings are in Auroville. You have seen our office. The first one was built in 1989. So our buildings that we have built in Auroville, although they have 33 years old. And we are in a tropical monsoon climate, which can be similar to your country, I guess. It means very hot and tropical monsoon climate with very high rainfall sometimes. We have, in general, for the temperatures in May, June, we have, from April, May, June, we have 38 to 40 degrees Celsius with 60 to 65% of humidity. We have rainfall in the monsoon time up to the maximum rainfall I have seen was 84 mm in half an hour. Imagine this much of rain, 84 mm in 168 mm in 1 hour of rainfall. In the cyclone time, we have up to 260 mm of rain in 24 hours, with rains totally driving with winds up to 153 kilometers an hour. And all our buildings have withstood this climate for the last 33 years. That means, I would say, with a good design and a good block, you can have what, I would not say hundreds of years, because this has not seen so long, but I would say more than us, in any case.
All right, she says, okay, great. Any further questions? We can take still have some time, Mr. Satprem?
Yes, yes, of course, there's no problem for me, as much as you want.
Perfect, thank you so much. I guess I see some people are typing, or I see some typing, but
I'm
questions.
sorry, I have another question.
Please,
Sorry, I
please.
have a lot. I really enjoyed your presentation. Do you also have some like connection with universities? So I'm thinking I teach here architecture and construction materials classes here in the Dominican Republic, and I would like to know if you are if you also have connections with universities to include this kind of courses like this at the distance, of course, for the students here. So like partnerships basically with universities.
In fact, no, we had several times a request from different schools of architecture or universities in India, but it never went through. Because in India, there is more demand from the students to have something more appropriate than the conventional techniques that they learned in their school. But these schools, they never went ahead to really integrate in their curricula what you can propose. No, we don't have any official link with any school or any university. But I have links, yes, I have links with France, with the School of Architecture of Grenoble, whereas Crater. So I was teaching once there. This stops for some reason, but I'm always in contact with them. But it's more on the academic level and for exchange of information, some research sometimes, but not for training people, not anymore. But this could be done if there is really the need in a country. We can imagine that you can set up some courses for you and so on.
Yes, I'm gonna think about it. Maybe maybe it's a good it's a good idea to build up a partnership for students here for future generations. You know, because you said one of the biggest challenges is about like cultural shift. You know, so I think if we start with future architects, maybe it's a good way of integrating this system in the construction industry. Thank you.
In fact, yes, this is the way to proceed because, in fact, you see, it's difficult for me to judge how far we have an impact in India and globally. But when I see that we have more and more requests for the training courses, when I hear from sometimes from far away that people have done this and this and that with our machines or whatever they have learned from us, it is encouraging quite sometimes, yes. And one of the problems that we have, I cannot keep track of the trainees that we have trained. And just sometimes as I hear, okay, this one has done so many houses here and there, like people in Gambia, they have done enormous work, but they don't keep in touch with us. I just know from word to mouth that something is happening. And to train the future generations of architects and engineers is really the key. That's why if you could have some teaching done in your school or university on that, this will be a great step forward.
Does that answer your question? Okay, perfect. Thank you, Mr. Rodriguez. Carmen Rodriguez proposed a question. He would like to know, where can he find the machines?
You have to buy them from India. They're produced in Auroville by the workshop Eureka. So they're produced here. In fact, we have also in USA Auroville Earth. They are kind of our representative in USA for these machines, but you can buy them from us. So directly, you just have to contact me. So give our contact details, and you can buy them from Auroville, not from us, because we don't sell the machine ourselves. The workshop Eureka manufactures the machines and sells them.
Well, Mr. Satprem, would you like to say goodbye or
yes, goodbye everyone. So have a good day, because it's morning in your place. So, and hope you can be here tomorrow for the next session.
Okay, perfect. Mr. Alejandro would like to know if you will be sharing the presentations.
Yes, I will send them. In fact, I thought that there was something to update in the CSCB lecture. I will send them tomorrow. I will send you everything tomorrow as a PDF, and you can share with everyone, of course.
Perfect. Thank you very much. Well, we would like to thank all participants. Once again, to thank Mr. Satprem. And tomorrow, as Mr. Satprem said, we will be speaking about building with arches, vaults, and domes, and also about Bioclimatic Earth. The session on Bioclimatic Earth will be held by Mr. Omar Rabie. Once again, thank you very much for joining us for the Introduction to Earthen Architecture seminar organized by our embassy together with the Auroville Earth Institute. And we look forward to receiving you all tomorrow. Once again.
Yes. Thank you, Anna, for your work, and thank you, David, for your initiative, in fact, because this came from David. And Anna did all the hard work behind. Yes, thank you.
Very much, Mr.
That's teamwork. And
Yes.
I will just conclude by saying that it's interesting that we have people from the universities attending the lecture, and architects, of course, and that I think we should explore some kind of connections with universities or through the universities to reach more architects and students in the Dominican Republic. But that will be at a later stage. So thank you very much.
Thank you. Thank you. Have a good day. Thank you.